go through it today. I'll give you kind of a little mnemonic to help you remember which one is which. So just get started here. Let's think about this guy right here. Look how happy he is. This is my stick figure that I got on Creative Commons. That's public domain. And he's looking up. He's happy. Look at him. So when we are elevated, we are actually looking up. That blue line represents what would be just a normal person looking straight ahead. But you know what? He's so happy he's looking up. So when you are elevated, he's looking. But when you're depressed, look how sad he is now. He's looking down. Again, a normal person will be looking straight ahead with the blue dotted line, but if you are depressed, you are looking down. So this is just the general way to remember. If you are talking about an angle of elevation, that is the angle up from a horizon. A horizon is going to be parallel to the ground, and it would be the traditional just looking straight forward. So if you're looking up at all, maybe at an airplane, maybe at the top of the building, maybe at the top of the tree, whatever the person is doing looking up, that is an angle of elevation. Meanwhile, if you are looking down, whether you are on the airplane in question, looking down at the ground, or maybe you're on top of a cliff looking into a valley, but you are presenting an angle of depression because you are looking down. Okay, so hopefully that mnemonic of the guy being happy looking up, elevated, or depressed looking down will help you remember this. Example here, we got Batman is cruising through the city and spots the bat signal high up in the clouds. You know that the GPS is exactly 2 miles from the police station where the signal is being produced, straight up in the air. I know that doesn't usually how it works, but just go with this. Okay. Signal has a maximum height depending on the cloud cover of 1.3 miles. Again, I know that's not how clouds work, but whatever. Okay, what is the angle of elevation? So the first thing we have to do here is draw out a diagram. Now, I would encourage you to kind of pause the video here and see if you can kind of replicate the drawing here and see if you can make sense of why this matters. And then go ahead and label the appropriate material here. Okay, so if we did that, then we should see that the height from the ground, or I should say the distance, is 2 miles. It's the first set of information that is given. Batman is 2 miles away from our police station. He is, or the height of the cloud, or the height of the bat signal we know is going to be 1.3 miles up from the ground. Now, and then finally the question is, what's the angle of elevation? So X is posted. Now, one thing I want you to realize here is, obviously this is not drawn to scale, but in some cases, this might matter. The fact that this guy right here has a certain distance up from the ground. But when we're talking about 1.3 miles off the ground, that 5 or 6 feet doesn't make, that's so negligible, it's not going to make a difference in the final answer. But if we're talking about feet, and maybe we're talking about a tree off of the ground, then that 6 feet is going to make a difference. So anytime you see something in here about how tall someone is, make note of that, because that's going to make a difference in the overall height, and it's going to make a difference in the overall answer. Okay, so watch out for things like that, but in this case, when we're talking about miles and feet, it's pretty negligible. Okay, so definitely not drawn to scale. The next thing you notice here is that we can draw this right triangle here because a height is going to be perpendicular to the ground and therefore perpendicular to the horizon, right? So this is a right triangle that we're dealing with. We have a 1.3 miles on one side, 2 miles on that side, and we're trying to find the angle. So of course, this is going to turn into a trigonometry problem. Okay, so I'm thinking to myself, okay, I've got my angle that I need to find. I've got this side and this side. What are those relationships to the angle? Well, I've got 1.3 as my opposite side, and I've got 2 as my adjacent side. Don't know the hypotenuse, right? So that leaves only one choice. I've got to use my tangent. Of course, tangent is opposite over adjacent. So I go ahead and fill in what I know. Tangent of x is going to be my opposite, which is 1.3, and then adjacent is 2. And then I have to take the arc tangent of both sides. On the left-hand side, it cancels. These two cancel here, and I'm left with x. And then I run to my calculator to type in this, making sure it's in degrees. And I get 33.02 degrees. Okay? No problems there. Angle of elevation problem. Depression problem. We have Superman is flying through the air and happens to spot a crime happening in the distance using his built-in inclinometer goggles, built by his friend Bruce Wayne, who has no relationship to Batman. He notices his angle of depression is 24 degrees, and his current altitude is 638 feet above the ground. If he were to fly directly to intercept the criminal, what distance would he have to fly? So before I click to the next slide, I want you to think about this. I want you to start sketching this out. Half the battle with these angle of elevation and depression problems comes from, can we sketch this out correctly? So we imagine Superman flying through the air, we see an angle of depression, and then we have an altitude, okay? So keep that all in mind, okay, as we go to the next slide. So does your diagram look something like this? Of course, we've got Superman flying through the air through Creative Commons, and then he's spotting that heinous crime. Look at that horizon. That's where he would be flying if he were to keep going straight. But because he wasn't going straight, he was looking down, okay? That angle right here is your angle of depression. I could skip back and just review again. Anything above the horizon is your angle of elevation. Anything below is the depression. We'll get to why I'm emphasizing this in a second, okay? But let's go ahead and fill in what we know. We know the angle of depression is 24 degrees, and we know that his height off the ground is 638 feet, okay? For this next step, you're going to have to think about how you're going to form the triangle, and in one form or another, you're going to have to use some sort of theorem to help you, either the alternate interior angles theorem, either a rule of complements, or you're going to have to use a rule of parallelograms, okay? Trying to find our x. That's the distance he has to travel. And now why are we doing it this way? Well, if Superman is flying, he's not going to fly straight and then just drop to the ground. Nor is he going to just suddenly spot a heinous crime, drop to the ground, and run there. He is going to fly in a straight path because Superman knows that the shortest distance between 2 points in Euclidean space is, of course, a straight line. Well, you know, there's something a little bit different about this triangle this time, okay? We know that we got this side length and this side length, but where are the angles? Well, we know that a height is perpendicular to the ground, so we're good there. That's a right angle. But where are the other angles? Well, here's what you have to figure out. This guy is going to be 66 degrees because if you think about it, the horizon is also going to be perpendicular to the height, right? That's going to be perpendicular. You could also say it's parallel to the ground, so we could say that these two angles are going to be supplementary, however you want to think about it, but these two angles right here are going to be complementary, so they have to add up to 90 degrees. I got 66 degrees from subtracting 24 from 90. Hopefully that makes sense. Now that we got our triangle, we can ditch the drawing and we can go back to trigonometry, okay? So we're trying to find x. We have this angle here and we have this side length. We think to ourselves, okay, this is adjacent to this side, and of course this guy is the hypotenuse. We do not know anything about this opposite side, okay? So that restricts our trig function to be cosine. Cosine is adjacent over hypotenuse, okay? Fill in what we know. We know that the angle in question is going to be 66 degrees. We know that our adjacent is 638 and our hypotenuse is x. Now I already clicked on the next step and you can kind of see what trick I'm doing here. Now I'm unfortunately unable to do this kind of vertical fractions here, but what I did from this step to this step was I turned it into a proportion. I wanted a ratio equal to a ratio because I'm about to do this really fancy trick using the third proportion rule. I'm going to flip the two. I'm going to flip the numerator with the opposite denominator, okay? I'm going to switch x and cosine of 66. It's a little bit easier to see if you write it out as proportions, but it is rule number 3 that you can switch the numerator with the opposite denominator. And why did I do that? Well, because now I have x over 1, which is going to be x, and then I have, so I've solved for x essentially, and then I have 638 divided by the cosine of 66. That I can just throw straight into the calculator. Again, making sure I'm in degrees, I get x is equal to 1,568 feet, 0.58. 0.58 feet. So yeah, Superman's got to get his butt in gear to get over there. Okay. Important thing to remember with this, and this is the number one thing I see students miss, the number one thing, is that the angle of depression is not inside the triangle that we care about. If you want, you have a couple of different options here, but if you want to put that angle of depression inside your triangle, you have to put it at the bottom of the problem. You have to put it at the base. You cannot put it at the top. If you want that top angle, it's going to be the complement. You have to do 90 minus the angle of elevation for the top angle. Here's what I mean. This guy right here is your angle of depression. Notice he is not inside the triangle. If you want to use the angle of depression, well, you have to know a quick rule here. This horizon is going to be parallel to the ground. Since they're parallel, alternate interior angles are congruent. So this guy right here, this angle at the base, that can be used as your angle of depression. Otherwise, if you're like me and you want this thing right here, you have to do 90 minus it. You cannot say that this guy is your angle of depression. I see that mistake every single year, that a student puts the angle of depression at the top of their triangle, and of course they solve it incorrectly. The end. Taken from Creative Commons, so I can use them. The end.